external anatomy first. I like this one better. On the anterior surface, the major component, of course, is the cornea, which, because the preservative is cloudy, which you realize in life is clear for that light through. Surrounding it is a major layer called the sclera. But on top of the sclera is a membrane, right here, called the conjunctiva. Notice that the conjunctiva ends where the cornea begins, because you can't have a membrane over the surface of the cornea. It would occlude light. If you turn back, we can see that the sclera is where muscles are attached. There's several muscles here. Some fat for cushioning, but most importantly, coming out of the back of the eye is the optic nerve. So that takes care of the external anatomy. Any questions? Okay. If we go inside, we'll do the anterior part first. You can see the opening here. This is the pupil. It lies just behind the cornea. A ring of tissue around the pupil is the iris, which has a muscle inside that can change the diameter of the pupil. So under bright light, it reduces, and light light, it opens. Next to that is a band of tissue called the ciliary body. It's two major functions. One is that it produces a fluid called aqueous humor. That fluid flows in and around the cornea. So on the cornea on the outside has tears going over it to help provide nutrients, but on the inside it has the aqueous humor. It does the same thing. The aqueous humor then empties into the canal schlemm. What's that called? Venous. I forget the name of it now. It's not on there because it's too small to see, but empties into a venous channel, and waste materials are washed away. So we have pupil, iris, ciliary body. The second function of that ciliary body is that it has muscles inside that are attached to small string-like ligaments. In fact, you can see them on the vitreous body here. If I move it, it's like strings coming off. That represents the suspensory ligaments. Therefore, the ciliary body can change the shape of the lens. In life, the lens would not be hard like this. It's much more flexible. Behind the lens, then, is the vitreous body that fills up the internal cavity. And someone earlier asked, what's the function of that thing? And the way I see it is the back of the eye is covered with this very, very fine film called the retina. And the vitreous body is in this area. I think it serves as a structure that keeps the retina from floating away. It happens sometimes when you hit in the head real hard, you'll get retinal detachment. That can be pretty dangerous for vision. But at any rate, on the inside of the posterior cavity in here is this film, which is the business of the eye. This is the retina. The retina is attached. You can see, I can even pick it up here. See where it's attached right here. And on this one, you see where it's puckered. It's attached right there. That's the blind spot that leads to the optic nerve. Beneath the retina is, this one shows it better. This again is the retina I just pulled out. Beneath that is a dark area. I'm pulling it away here. This is the choroid. The choroid in the human is all black, so the inside of the human eye is all black. But in nocturnal animals that are required to see in dim light, it has this band of iridescent material called the tapetum lucidum. We don't have that, but they do. And the way it works is that what light there is available kind of bounces around the eye and allows them to detect more images in dim light. behind the choroid, then again is the sclera, which gives the shape to the eyeball. Back here to the, one thing I forgot, back here to the ciliary body, you can see that it's corrugated, except corduroy, and the edge is serrated. So the edge is given the name ora serrata. Ora means around, serrata means saw-like. Any questions? That pretty much covers it. Okay.